Alright guys, welcome back to this channel, and in this video I'm going to be solving a linear programming problem using Simplex method. This operation research. Consider a question like this: minimum of z is equal to 2x1 minus 3x2 subjected to x1 plus x2 less or equal to 4, x1 minus x2 less equals 6, and x1 x2 is greater than 0. So now, how do I know that this is going to be solved by a simplex method? There are steps to follow when using simplex method. Number one is convert the problem to objective function constraint form. All right. Number two, convert the objective function constraint form to standard form by changing all the less or equal to and add slack variables to each constraint. The next one, you have to see or identify if your question is a maximum or minimum question. Then, to consider using simplex form, then the quality of the constraint should all be less or equal to. If we have greater or equals to, then we consider using two-phase or big M method. Let's put all this into practice. Going back to our question, convert the following problem to objective constraint form. The question that we are given is already in objective constraint form, meaning that minimum z equals to 2x1 minus 3x2 is our objective function. Subject to is our constraint. That means x1 plus x2 less or equals to 4 is a constraint. x1 minus x2 less or equals to 6 is also a constraint. Now, consider point 2, that we want to convert all of these to a standard form by changing all the less equals to equal sign. How do I do that? Now, I've changed all of the less to equal sign. You see that? That's the next thing you're supposed to do. Then after you must have done that, you are going to be adding slack variables to the constraint. So let me add the first slack variable. I'll call it x1. I'll add the second slack variable. I'll call it s2 to the second constraint. Now, this must affect the objective function. I don't want to alter the objective function, so I'll add 0x1 and 0x2, meaning that I'm just representing them there to be aware that slack variables has been added. I'll also add them to the conditions that they are all 0 greater than, they are all 0 and positive numbers. They can be 0 and positive numbers. The next is to be sure that this is either maximum or minimum. Now, in this question, we're dealing with a minimum objective function. So after we have confirmed all of this, then we are also sure that we are using simplex method because we all changed all of the less or equal to equal sign, and we were not dealing with greater sign. Much more than the 4 steps I've listed, we can also have more. Impute your data into your first initial table of the given form below. Now, the beauty of simplex method is that you are going to be working with a table after you must have confirmed the 4 first steps. This is how the table looks like. Now, I'll explain all of this part of the table shortly. Here, this Cj means that the coefficient of the objective functions. What do I mean? Consider the question that we are given from the onset, which we've added slack variables already. The coefficient of this objective function, that means 2 minus 3, 0, 0. They are what we are going to be writing here. Okay, that's for that. Then here is the coefficient of the slack variable. Meanwhile, they are the coefficient of the basic variable bv. So we start with slack variable. So the coefficients are going to be written there. And here, x1, s2 is where you are going to be writing your slack variables. After you must have written the basic variable x1, x2. If you have x3 in the question, it's going to be x1, x2, s3, then s1, s2, s3. Okay, slack variable. And here, this b will be where you are going to be writing your answers. That's the result of the constraint. That's 4 and 6. Then this R is what we call the key column. And this part of the table, I call it AIJ, portion of the table. So I multiply whatever I have in this part of the equation to this other side. I also multiply this part of the equation of the table. I add them together, that will give me my ZJ. That happens to the rest of the table. To this column, multiply that table and the column of XI, X1, then you get ZJ. Like that, and like that. So we can conclusively say that for the JZ row, you are computing the summation of CB times AI, each of the columns. Now let's put this into practice for a practical question. Suppose you have a question that we want to solve, then I'm going to fill up the coefficient of the objective function from the first part. That's 2, minus 3, 0, 0. Now let's fill up the CB. That's the coefficient of my BV. I'm starting with S1 and S2. That's how we start with 0, 0. Then I'm considering it from the objective function now. So let's fill up the table one after the other. You know, from the constraint of the first constraint, the coefficient of S1 is 1, S2 is 1, S1 is also 1, but there is no S2 in the first constraint, so I write 0. The result there is 4. So I'll just leave that for now. So the next one has 1, minus 1. Now there's no S1 and there is S2, right? So look at the result now, 4 and 6. That will be in the B column. So 4 and 6. All right. So I want to compute my ZJ just like I've explained earlier. 0 times 1 plus 0 times 1, that will be 0. I added it together. 0 times 1 plus 0 times minus 1, that's 0. So I'll do that for the rest of the table. Okay. Then, after I must have been able to get this done, I want to compute my CJ minus ZJ. That means this CJ row and this ZJ row. 2 minus 0 will be 2. Minus 3 minus 0, that's minus 3. 0 minus 0, 0. 0 minus 0, 0. Do you get that now? And now, after we have done steps 5, let's move to the next one, the key column. Now, if it is a maximum question we are dealing with, we will look at the CJ minus ZJ column, ZJ row I mean, with the highest positive will be selected, right? We will select it if it is the highest positive. If it is the maximum, we select the highest positive. And what about the minimum, which we are actually dealing with? We select the highest negative. Then we find R. The least positive R is the key row and the intersection is the pivot element. Divide the key row by pivot element and use this to reduce the other element of the column to 0 by row reduction. Let me explain this quickly. Look at the CJ minus ZJ row. You see that because I'm dealing with a minimum question, I'm going to be looking for the highest negative, which is minus 3. So I'm going to pick that column, just like I've explained earlier. I'll pick that column, and also I'm going to be dividing the rows, meaning that your B, which is 4, divided by that 1 in that column which I've selected. I'll do this for 6. You know, we have minus 1. That's 6 divided by minus 1, that will be 6. Now I'll look for the highest positive. Find R. How do I get my R? The least positive, that means the positive number, then the least positive is the key row. That means my key row is this. That's the least positive, right? Because minus 6 is negative. Then the intersection of these two lines is our pivot element, which means that 1 is our pivot element, right? Then I want to divide the key row by pivot element and use this to reduce the other element of the key element to 0 by row reduction. What I basically want to do is this particular row that I've picked, which is the row 1, I will divide it by that intersection 1. Okay, so, and I want to make this minus 1 to be 0. That's what this element means. I will reduce all of the elements below that key element to become 0. All right, so how do I make that happen? I will just say row 1 plus row 2, that means 1 minus 1 will be 0. So this, and before I go to the next table, no, this is still our initial table. Minus 3 we replace 0, and next we replace s1. S2 we replace s1 because that's our key column. All right, we are going to be replacing those stuffs, and we move to the next table. Just quickly do that. Now I want to do the row reduction basically, so I replace that as minus 3 and I replace this as minus 2, right? So what do we do next? Row 2 will now be 2. I added what was there before. Row 1, so that will be 0, 1, 1. All right, so I haven't done that. You know how we compute our zj the other time. Minus 3 times 1 plus 0 times 2. So that will give us the zj. I've explained that before we got here. So, and how do we do cj minus zj? I'll just do 2 minus what I have earlier. That will be 5. Let me quickly correct this one. Here, this is supposed to be, I'm actually doing minus 3 times what is minus 3. This is minus 3 here. Okay, so 2 minus minus 3 is 5. Okay, so that's correct. So let's move on to, so now that we have achieved the old table, then we'll move to the next condition. Now if we are solving the minimum objective question, which is what we are currently doing, after we have done the row reduction, we are going to check if the cj minus zj, if all the elements are greater than 0. If we can achieve that, then we will say that we have reached an optimized solution. Else we are going to repeat step 6. Meanwhile, if we are dealing with a maximum objective function, we are going to be checking if all of the elements in the cj minus zj row, if they are all less than 0. If it is, we've gotten to an optimized solution. Else we repeat step 6. Just quickly confirm that if we reached an optimized solution. Look at this. We have 5, 0, 3, and 0. Are they all greater than 0? Yes. Since all of them are greater than 0, then we've reached an optimized solution. So let's bring them out. What are the optimized solutions here? x2 will now be equals to 4 because b serves as our result. s2 will be equals to 4. zj will be equals to minus 12. So x2 is equals to 4. Now because I later did not have x1 in my bv column, my basic variable column, x1 becomes 0. And that's it. Very easy. Don't forget to like, share, subscribe to this channel. Let me know what you feel about this video in the comment section. Let me know if you want me to also work on big M and You can ask a question in the comment section. Most importantly, don't forget to like, share and subscribe to this channel if you have not subscribed yet. And I'll see you in the subsequent video. Bye for now.